Hi and welcome. My name is Roxana and I will be talking about my internship inquiry project, Coding for Math Teaching and Learning. So, why coding and math learning? Well, how many of us have experienced this, or this, or this, and especially at times this? Well, I know I have. Learning to code can be an extremely difficult and intimidating task if you've never done it before. And as such, seeing its benefits and affordances can be difficult until you become proficient at it. So my inquiry question was, what affordances does learning to code provide IS/BEd students in teaching and learning math concepts? Well, let's start with where I did my internship. Well, I did it right here at Ontario Tech University with my supervisor, Diane Tapello. And I used the previous cohort's weekly journal entries for the IS/BEd students. So there were 6 main reasons why I chose to do my internship. First, math is one of my teachables. Second, I want to improve my own math instruction. Number 3, I want to integrate cross-curricular connections into my math classrooms. Number 4, I want to know what affordances coding can provide to students in learning math. And to go along with that, number 5, I want to know what affordances coding can provide to teachers in teaching math. And lastly, number 6, I want to broaden my views and perceptions of coding. I know that I've been interested in coding for a very long time, but that could not be, I can't say the same thing for a lot of my colleagues and friends, and I know I won't be able to say the same for a lot of my students. And being able to see others' perceptions and ideas surrounding coding will hopefully broaden my own views and ideals when teaching it. So my learning goal for this project was that through the use of NVivo, I will be able to assess IS/BEd students' perspectives of their learning and teaching of math concepts with coding. I also had 5 success criteria for this learning goal. The first was to identify areas of student reflection that pertain to math learning. Second was to determine which math concepts students find they can learn through coding. Third was to determine what benefits students see to using coding to teach math in their classrooms. Number 4 was to identify which math concepts students think they can teach through coding. And number 5 was to identify students' perceptions of learning math through coding. So the inquiry model I used was the inquiry model of learning, which has 5 steps. So the first was to ask the question, which I did in the form of my inquiry question, of course. The second was to gather and organize the information, which I did by reading through all of the journal entries and picking out key phrases that pertain to math learning and students' perception of it. I then interpreted and analyzed that information, seeing any trends that came out or material that constantly repeated. I then evaluated the information and drew conclusions, and will communicate the findings both to you as well as to my supervisor. So, what does the research say? So I did a lot of research and read a lot of articles, and they had very much a consensus. Coding provides several benefits to learning math. I picked 3 articles out of the many that I did read to talk about, as they provide clear guidelines as to the precise benefits to math learning. So the first was a 2017 article by Gadenius, and they said that coding provides a gained understanding of the abstraction that lie at the heart of mathematics. Coding provides an ability to dynamically model mathematics concepts and relationships, and it gives students a gained confidence in their own ability and agency as mathematics learners. The second article was also by Gadenius from 2015, and he said that coding uses a low floor, high ceiling, and wide walls approach and allows for the creation of activities which can be used to teach abstract concepts currently thought out to be out of reach for children of a specific age group. And the last paper that I will talk about today was a also 2015 paper by Misfeld and Xing Dun. And the authors of this paper identified that coding supports mathematic learning in 3 specific ways. First, students are viewed as the producers. Coding supports abstract thinking, and it supports the development of algorithmic thinking. So, what did I find in my research? Well, most instances of math learning being noted occurred in week 1 and 2, with a steady decline starting at week 3 and going to week 8. But the math learning that was noted from the coding that was done in the ISB Ed course that we are required to all take was the ideas of the angles of a shape related to the number of sides of that shape, concepts of interior and exterior angles, the Cartesian plane, positive and negative integers in different variables, rotations, transformations, and scaling, properties of sinusoidal functions, domain and ranges. It develops graphing skills. We also develop some probability skills. And lastly, we also develop problem solving and free inquiry skills. So in conclusion, coding is a fun and interactive way to teach and learn a wide range of mathematical content, no matter your age or proficiency level. And ISB Ed students identified several areas of math learning that they took away from learning to code and can implement in cross-curricular connections within the classroom. And lastly, in my future classroom, I will be able to implement coding as an instructional method for teaching math. Thank you for watching.